In this video, we are going to cover all the concepts you need to know to solve physics examination questions on falling objects. This is just one of a series of physics kinematics lessons to help you study smartly and prepare successfully for your physics exams. Examination questions on falling objects fall into three categories, testing your concepts of falling objects in the following three areas. The first type of question tests the most fundamental concept that you must know about falling objects. That is, they fall with increasing speed or velocity. Most of the time, objects fall so fast that we have the misconception that they fall at constant speed, but that is not true. They fall at increasing speed. In other words, they accelerate as they fall, and this acceleration is a constant at around 10 meters per square second for objects near to the surface of the Earth, or for objects in a vacuum. The reason why objects fall is because of the pull of the force of gravity exerted by the Earth. And it is because of this reason that they fall with increasing speed, or we say they accelerate as they fall. In fact, this is in accordance to Newton's second law of motion, which states that when there is a resultant force acting on an object, the object accelerates and the product of the mass and acceleration of the object is equals to the resultant force. So, all falling objects being acted upon by the force of gravity will fall with an acceleration. That brings us to the second type of questions, which test our knowledge on what is the difference for objects falling in vacuum and for objects falling in the presence of air. In vacuum, there is no air, so there is no air resistance. The only force acting on the object is the force of gravity pulling it downwards. In the presence of air, there exists a resistive force, air resistance, which is a frictional force that opposes the downward falling motion. This air resistance will reduce the increase in speed as the object falls. The faster the object falls, the greater the air resistance will become. So objects falling in vacuum will experience a constant acceleration of 10 meters per square second all the way. Whereas objects falling in the presence of air resistance will experience a situation of decreasing acceleration as the air resistance increases. In fact, the acceleration will continue to decrease till it reaches zero, and that is the time when the air resistance becomes equal to the downward weight of the object. Hence, objects falling in the presence of air resistance will experience a stage where they reach their terminal velocity. That is, when they continue to fall at constant velocity. Note that when terminal velocity is reached, the object is still falling. It is not floating in the air. The object is falling, but its velocity is not increasing. This is the maximum velocity that the object can reach. Note also that this is a stage where the downward weight, that is the force of gravity exerted by the Earth, equals the upward air resistance. So it means that the two forces, the downward weight, the downward force of gravity, equals to the upward air resistance. These two forces are balanced, which means that this is a stage where the Newton's first law of motion applies. Newton's first law states that every object will continue in its state of uniform motion in a straight line unless a resultant force acts on it to change its state. So, when the object reaches terminal velocity, it continues to fall at constant speed because the forces acting on it are balanced. Because air resistance is a resistive force that increases with surface area and increases with increasing speed, the time for different types of objects to reach the ground will depend largely on their surface area, size, and shape. However, in the absence of air resistance, that is in vacuum, all objects, large or small, will fall with the same acceleration of 10 meters per square second and hence will reach the ground at the same time. The third type of exam questions on falling objects will test your knowledge about whether the object will fall faster or slower when it is placed in a planet with a stronger or weaker gravitational field strength. You see, objects fall to the ground because of the gravitational pull of a planet. Yet planets have differing gravitational field strength. For instance, the gravitational field strength of Earth is 6 times stronger than that of the Moon. If you pull an object with a small force, it will move slowly towards you. However, if you pull with a much greater force, you'll find the object accelerating towards you. With this concept, if Earth's gravitational field strength is 6 times that of the Moon, you'll know that objects on Earth will fall much faster than on the Moon. With all this knowledge, you should be able to solve any O-level physics exam questions relating to falling objects. If you find this video useful, do give a like, subscribe and follow us. Visit our website to access to more free physics lessons and try out the self-assessment questions to reinforce your understanding.